In this video, we demonstrate our visual analytics framework for exploring algorithmic fairness in graph mining models. After opening the system, the panel on the top left shows the information of the graph mining model, the dataset to be inspected, and the mining results. As we focus on the ranking task in this work, the histogram shows the ranking score density distribution. The histogram supports interactions such as brush selections and ranking range customizations. This is done in order to help users select a set of target nodes they care about. The top right panel allows users to select potential sensitive attributes to form protected groups. Users can inspect the distribution of each attribute on the attribute view and understand the distribution similarity between selected nodes and the whole population. The panel supports customizing distribution similarity metrics and transforming the attribute from continuous values to categorical values for future diagnosis. The selection of target nodes and sensitive attributes will automatically synchronize all corresponding views, and users can then inspect fairness from a variety of aspects through such views including the group table view, the rank mapping view, the group proportion view, as well as the group shift view. We present an example where Facebook's social network is ranked by AtraRank. Since this ranking task can be used for recommendation, graph ranking developers and researchers may be interested in knowing if users are being targeted with unfair recommendations where certain nodes are treated with biases such that they receive low exposure rate due to the low ranking. We decide to explore top 25 nodes as their ranking positions are more important. Since we don't know the attribute information, we explore different combinations of attributes to see possible definitions of protected groups. The attributes view shows that many attributes lack data for future analysis, thus we avoid defining protected groups based on them. We find the attribute gender and attribute locale have disproportionate distribution among selected nodes, and those colored in blue who have gender value feature 78 and locale value feature 127 have a greater portion than others, which raises the question if the ranking model gives precedence to nodes with these demographics. In the group proportion view, we observe that the large proportion of the group mentioned above also exists in the ranking result of PageRank, which means such group originally has higher utility or relevance than others, and not because of model manipulation. On the contrary, the group proportion view and the group shift view show that the blue group is treated disadvantageously as the average ranking decreases after performing AtraRank. We then explore the content bias in the ranking results. By setting the ranking score similarity threshold 0.0005, we find there are 5 clusters formed from the results of both ranking models. And from the last 2 clusters of each side, we can see the nodes have similar ranking scores, but they received different ranking positions with up to 15 rank position differences. Finally, we explore AtraRank's behavior on individual nodes. We find that the node with ID 1199 has a significant ranking drop from 11th to 21st, which shows individual unfairness can happen and be affected on such nodes. We demonstrate how fairness researchers and ranking model developers inspect the behavior of a de-biased PageRank model in form in order to make ranking results of a available dataset follow its fairness constraints. This time, we select top 50 ranked nodes, as they cover most of the nodes that belong to the different ranking ranges, and they are more important than others. We find attributes of gender and followers are the protected attribute class of interest, since the attributes view indicates that females and males have the same proportion among the top 50 nodes, while females have a larger proportion than males across the entire dataset, and nodes who have more than 10 million followers make up the largest component among the top 50 nodes. The group shift view indicates that the average ranking of the group ID 02 with attributes of male and followers under 10,000 is increased by 2 positions, which indicates the informed model indirectly shows preference on this group, although the group proportion view shows this group has small proportion changes before and after applying the informed model. Finally, we explore and set the ranking score similarity threshold as 0.0035 and find the top 50 nodes are clustered into 6 clusters. Each cluster has relatively more nodes than those of the base model. This indicates that Inform tends to manipulate nodes to have similar ranking scores in order to reduce the individual bias. However, it has also made the results to have larger content bias. For example, the nodes of cluster on the 4th row are ranked from 7th to 11th. However, they have similar ranking scores with differences less than 0.0035, which are supposed to receive similar exposure rates.